Well, hello everyone. Welcome back to Adrian's Digital Basement 2. You know what this is because you clicked on the thumbnail. It's a super mini mail call. And we have a package here from Lawrence in the UK. So hi to all my UK viewers. Let's open this up. No dawdling for me. And we have a note with a picture of Rammy on it. Let's take a look at the note first. Hello, Adrian. I thought it was about time I sent you another box of delights, as my workplace is having yet another clear out. You would be aghast at how much stuff is being thrown away. Anyhow, this box contains a mix of boards, processors, miscellaneous ICs, and other hardware. I hope there is something in here which you'll find interesting and or useful. Gan Kanimara, Lawrence. P.S. I have not seen much of Rammy lately. You know, that's actually a complaint I've had from quite a number of people. So with that said, let me go grab Rammy, and Rammy will be out for the rest of this video and maybe a bunch more. Rammy normally sits over there, sort of, there's a window back there, in the window, looking out the window. And I just forget to bring Rammy over to my bench. So I'm gonna do that right now. Okay, here's Rammy, ready for the supervision duties. Let's see, can I keep Rammy in camera here? If I turn that a little bit. Okay, stay Rammy, stay. So we have lots of really, well, this box is amazingly packed. There's like perfect jigsaw puzzle level pieces here. That's pretty amazing. Okay, so we have a bunch of tubes of ICs here. And then we have a bunch of very well-packed little boxes. Looks like 4 right there. And another one here that is larger, which I assume has some PCBs in it or something. And that's it. So let's try to get a little bit more organized here. And we'll just, I don't know, let's start with this box over here on the right. I'm using this little slicer here. I think Seth sent this in. It's actually not bad. It has a tiny little ceramic blade, but it's actually good enough to cut through most stuff. Oh, okay. So we have a Pentium processor here, a Pentium 3 specifically. So this type of Intel package is slot 1, but if you got this in the consumer marketplace, you typically had a little bit nicer looking of a heatsink. This is a passive cooler, obviously, because the computer that this would have been in would have a fan near this somewhere, maybe a shroud that went over it. I think I saw a lot of this in like Dell and HP and whatever type computers, stuff like that, OEM level stuff. As far as removing this heatsink, I think it is technically possible, although I can never really remember how this all comes apart. I'm not sure if those are screws or are those not screws. Let's see, enhance, enhance, enhance. Yeah, I don't know. Those look like some kind of plastic clips. As far as this processor goes, you could tell we have a Pentium 3, a nice little picture of the die. But if we look there, 733 megahertz, 133 megahertz front side bus, 256K cache, L1 cache that is, and 1.65 volts made in Malaysia. Now, I don't really feature a lot of stuff with Pentium 2s, Pentium 3s, Pentium 4s on the channel because all of that stuff just feels too similar to what we have today. Now, while a Pentium 3 can make a pretty good Windows 98 gaming machine, and in fact, behind me, there's a couple PCs I have there sort of permanently set up to hooked up to a KVM in the monitor there. I have a Pentium 3 at 1 gigahertz. That machine has Windows 98 on it, and it also has Windows XP on it because occasionally I need to run XP stuff, and I don't know, it does a fine job at that as well. It's a bit slow actually for XP, but Windows XP doesn't feel that far removed from Windows 11, and we have like whatever the current version of Windows is today. So the fact that you can run it on these types of processors just makes this feel not really retro. It just feels like a really, really slow version of a 32-bit processor you could have today. I don't know, you know, talking about this actually, it's really hard to even justify. I think retro is something that is up to the eye of the beholder. Like whatever your interests are, whether you think it's retro or not is up to you. And while I don't feel like a Pentium 3 or Pentium 4 is retro enough for me to really spend my time on, by the time we had Pentium and then really into the Pentium 2 and beyond, computers were ubiquitous, commodity. They had gotten very cheap, meaning like every corner had been cut to make a really inexpensive computer you could just go anywhere and buy. They just didn't feel special. There wasn't a lot of differentiation from one computer to another. They just were all essentially the same beige boxes with some like restyling going on on the outside of the case. Going back much further though, to something like the 5170 that sits here next to me, that thing is like heavy steel and it's a pain to use and it's not really user friendly. It doesn't have a menu driven BIOS. There's like so much different about it that it feels a little foreign. I think if you plop down like a modern PC person in front of a Pentium 4 or a Pentium 3 computer, they'd run the BIOS and be like, okay, I understand how all this works. And you put them in front of my 5170 here, they're not gonna know what to do with that thing. Like, you gotta boot a disk to try to get to the menus, and it has these cryptic error codes, and that kind of weird difficulty thing is what makes that sort of the special era for me. Okay, anyways, moving on. I think I probably upset like half the people watching at this point. Let's move on to the next little box here. Okay, I'm having trouble opening this box. I think the issue with this little tiny blade is sometimes if you're trying to cut tape that's in grooves, it doesn't work so well. So I'm gonna get out the big guns. Well, this one actually says right on the top, turned pin IC sockets, which turned pin is another word for round holes. Oh yeah, very nice. This stuff is extra super usable. I use this stuff up all the time. So these are 40 pin dip packages, but they're very tall. So if you install this into a PCB, it would stop right there. So the CPU would sit pretty high up. Now that can be useful if you have another package underneath here, like say you have another IC installed, or I don't know, you're just trying to raise something off the board, like you're trying to plug a small adapter PCB, like the ROM emulator, into a motherboard, you need to raise it up. So these types of sockets are quite useful, and I actually don't have any. So that's pretty cool. So we bunch of 40 pins. We have a bunch of long pin headers. Look at these little pieces of foam here. It's just absolutely amazing, Lawrence. This packing is quite incredible. These types of sockets here are perfect for EPROMs and larger ICs, obviously. We have a zero insertion force socket. It's a pretty cool design, actually. Click this on and off. This actually let you leave the chip in place, but flipping this actually turns off the chip. So like it breaks the connection between the pins of the IC and the motherboard. I haven't seen one of these before. And looking in the rest of this, there are just tons of sockets, and these seem pretty nice quality as well. I absolutely love these particular types of sockets, and this will be great to replenish my stock. So this is extra super useful. Excellent. Thank you very much. Moving on to the next box. Let's say we have some kind of a video card, probably AGP, I am guessing. Yep, it is AGP. And there it is. It's an NVIDIA GeForce 128 megabytes, so an FX 5200. There's an NVIDIA logo. So that is the AGP style connector, Advanced Graphics Port, I think it stands for. The idea of AGP was to improve the performance of PCI, and this was before PCI Express existed. PCI was 32-bit at 33 megahertz, at least the standard consumer size connector. And this, initially when it came out, was 32 bits at 64 or 66 megahertz. But then very soon after that, there was like AGP 2X and 3X, which I think gave, I don't think more bits, but it gave higher speeds. I don't remember the specifics, but most graphics cards before PCI Express came out utilized AGP just because of the additional performance improvement. Now, some graphics cards, I don't know about this one, and probably not this one, they were designed for PCI. So when you used them on AGP, it used some kind of an additional IC to bridge AGP to PCI, and you got no performance benefits. So there was no reason for even using that card. And yet, well, unfortunately, these are companies that wanted to try to sell an AGP product, but it was a real scam, actually. And this card here has DVI video. Oh, this is not normal DVI. This is weird. Hopefully the cable's in the box here, because this is not standard. Don't remember what exactly the difference is, but I don't think normal DVI looks like this. Looks like there's some more cards in here. Maybe another one has DVI and it will have the more standard DVI connector. I don't really remember the specifics on those weird DVI connectors. Like that one there might be for 2 monitors. Like you had a little breakout cable that would then allow you to plug in 2 flat panel displays. And the reason why is, notice this card is low profile. So they made this short like this so that you could use a low profile slot, bracket, plate, whatever this thing is called here. And then you could use this in a low profile desktop computer. This is like very big for businesses. But then for dual monitors, if you wanted digital, you needed to use a breakout cable. And that was the reason for this kind of weirdness here. All right, so next up is a regular PCI Promise Dual IDE controller and a disk, Promise Ultra 33 hard drive controller, Windows 95 drivers. Yeah, so if you wanted to add 2 more IDE ports to your motherboard, you would use something like this. I think for Windows 95 to get like 32-bit support and whatever, you had to use a driver disk. But I think the BIOS on here would allow this to work and maybe even boot from those additional ports. And this card, unlike an ISA IDE card, has different base IO and whatnot, so it doesn't conflict with what's on your motherboard. You can have it and coexist. And I'm assuming actually you could probably put more than one of these in your computer to add more and more IDE ports if that's what you wanted to do. And this was the last card in that box. So we have a Cirrus Logic ISA video card. So this is certainly a little bit more up my alley because it works with things like 286s and 386s and stuff like that. I found Cirrus Logic cards aren't the best. They're not the fastest. If you're talking about ISA video cards, it was the Sang ET4000s generally are considered some of the best or the fastest, but these are okay. What I remember about these Cirrus Logic cards, and this is 5428, there's a few different models in that GD54XX series. They are 2D accelerators, so there's no 3D acceleration, but it does accelerate 2D. So if you have the right drivers for this in Windows and you're running in like 256 colors or even 16-bit color in Windows 3.1, things like scrolling or moving a window around, so blit operations and all those types of things are accelerated by the GPU, or it's not a GPU, whatever, this graphics display processor, I guess you could call it. And it allows for some giant speed ups. Now the ISA bus is pretty slow. So if you're pushing those pixels around to say scroll a window and over the ISA bus, because the CPU is doing the work, you get some pretty bad performance if you're running in especially 16-bit color or 24-bit color. Now, the thing that reminds me the most about this card is I first started using Linux back around 1993 or 94. It was a very early pre-1.0 version of Slackware. I had an Amiga at the time, and I remember the Amiga had, of course, graphics acceleration, and I loved that thing. But I was really amazed when I installed Linux on my 486. I think it was like a 33 megahertz 486. I had a PC and the Amiga at the same time. The PC I didn't use as much as the Amiga, because, you know, Windows 3.1 and DOS, you know, just not that good compared to the Amiga at the time. At least that's what I felt. But I put Linux on the PC and I had this video card because my 46 was like an older one. I didn't have local bus or anything like that. I'm not even sure local bus was out at the time. But I remember that X Windows or x86 supported the acceleration on the Cirrus Logic card because I had a card like just like this. I don't remember which chip it was. And I remember being completely amazed when X Windows loaded up, and I don't remember which window manager it was back then, but it was very, very primitive. But when I grabbed a window and I moved it across the screen, I remember that the way it was configured in x86 is that it didn't even drag an outline. It dragged the entire window, you know, as the mouse pointer moved. And that was the first time I'd ever seen that. Because even on Macintosh 2s, the fast Macintoshes at the time, they just dragged an outline. And on the Amiga, I think it dragged the outline as well. And then it would move the window after the fact. But on x86 with this card, it was able to drag the whole window. And I remember I was like, how is this doing? This is so fast. But then I read up about the fact that it was using the acceleration features in this card. And then I knew if you installed those drivers Windows 3.1, which I think I had at the time, then it could theoretically move the entire window that way, but it didn't. Windows 3.1 always just dragged an outline, even if you were using the drivers. And that was only later, like Windows 95 had like a power toy that you could turn on, and then it would actually drag the entire window and use the acceleration on your card. But that was my little story about x86 on Slackware and just being amazed that the Cirrus Logic could do that. There's no 3D acceleration or anything like that, of course. This card is way too old for that. But those 2D acceleration capabilities really do help, especially when you're hampered by the really slow 8 megahertz ISA bus. So with that NVIDIA card, I came to Wikipedia here to take a look at the DVI interface. And indeed, this is the normal DVI-D interface, so digital. DVI also has the capability of carrying analog signals and has extra pins right here around this slot right here. But if I grab the card, the problem is with this card here, does it focus? Stop focusing on my face. You can see here that that thing is not compatible with the connector that we see on the screen there. That slot there has nowhere to go. So there's no way that this cable, which is the standard DVI cable, will work on this card. Okay, so here's a different connector. So yeah, dual link allows for like double the bandwidth. It was usually necessary I don't necessarily think to run 2 monitors, but to run much higher resolution monitors, because the original DVI standard, it just couldn't push the high enough resolution over the standard single link cable. Quad link connector, but all of these still have these extra pins on the side here that could carry the analog video. Yeah, unfortunately, that's it for this article. Doesn't really mention anything about this connector on this NVIDIA card. So this obviously is proprietary, and you do need that splitter cable. So just beware if you're trying to buy one of these online that you don't end up with a card like this that you cannot use. Okay, let's dig into the next box here. All right, so we have another Pentium processor. Oh, it's a Pentium 2. I was going to say, is this another Pentium 3? Nope. It's a Pentium 2 with MMX technology. And here is information. I'm going to guess we have a 266 megahertz processor with 512K of cache. And yes, it seems like it's more cache than that Pentium 3 we're looking at. But this cache, I'm pretty sure, is going to be different in that the other one was on die and this one is external. And because it's external, it runs at a much slower clock speed. All right, with the screws off, there we go. That popped off. Oh, this obviously is a heat spreader. I was kind of assuming we'd see the processor under there, but nope. You can kind of get a glimpse through this hole there. I think the processor is right here underneath the heat spreader, but there are chips here, SRAM chips, that are used for that level 2, or is it level 1 cache, I guess it's called. It might be called level 2 on this processor, because I think there's a small amount of level 1 cache, then there's this cache, and then whatever might be on the motherboard, that would be level 3 cache. Meanwhile, the Pentium 3, and I started to think with the Celeron 300A, which is a chip I had, what they did is they got rid of, can we see that here? Yeah, you can just make out there are no additional chips on here. It's just the main processor. So it has all of that cache memory, which I think was 256, contained on the die itself. So I guess it still counts as level 2 cache, but it's much faster than the level 2 that's on here, because I think this cache runs at half the speed of this Pentium 3. Speaking of Pentiums, there's another one in here, and this one has an aftermarket cooler on it. Look at this beast. Yes, it's big and chunky. Oh, it's an AMD Athlon. So this was a slot A. So AMD wanted to get in on the whole slot processor game, I guess. Talk about following the leader. Like, did anyone actually think that this slot 1 was a good idea? I don't know. But AMD was like, well, we're going to copy it. And they sure did with their Athlon chips here. So there you go. You can see it's a K7 at 600 megahertz. I don't know how to read the rest of that there. But yeah, this is aftermarket. And maybe we can pop this off somehow. Let's see. There we go. And look at that design. Very similar. We have a heat spreader. We have this. I mean, the whole thing was just silly. And again, like this era, I kind of skipped over all of it. I'm trying to think back to what I had at this time. I think I went from like a Pentium MMX 233. So that's a slot 7 type processor. I think the next thing I had after that was an AMD Athlon, which was not this. Well, I mean, I guess it was the successor to this, but installed in a chip on the motherboard. So I never had any of this slot 1 or slot 8 stuff. And I remember thinking this stuff was dumb. Like, I was not impressed with it at all. And when they, Intel abandoned it and AMD abandoned it and went back to a chip on the motherboard, which is, what we still have today, just like, what were they thinking here? Like, this was somehow better. In what way exactly? In what way was this better? Anyways, I think that's what this is here. So if you had a multi-processor system, say it has the capability of running with 2 Pentium 2s or Pentium 3s, some of them required you to insert this little board in here, which was essentially a terminator. I don't know why I'm not just using the top-down camera. There it is, top-down camera. So it's, it's just a bunch of resistors to terminate the bus so you don't have a bunch of reflections and whatnot on that high-speed bus. 133 megahertz, I think the Pentium 2 or Pentium 3 could run at. And if you didn't put one of these in there, then you would have some issues. So which one is this? Yeah, I'm going to say that this is definitely a slot 1 adapter. I'm pretty sure that the AMD is different. Okay, I was going to say the AMD slot is different. It doesn't really look different. I don't really get why AMD literally copied slot 1 exactly. That seems absolutely ridiculous. I didn't even know that. That's electrically, it's obviously not compatible. I don't think, but I figured that slot would be somewhere else, so you couldn't accidentally put this processor into an Intel motherboard because they weren't compatible. Anyhow, we have a few other little goodies that were in that box. It looks like we have some 1 megabyte 30-pin memory modules from 1992. So these are great. One day I'll do a big RAM test video. Of course, Rammy approves of the RAM. And I'll need to do something, maybe a live stream or something for patrons where I will test memory and then chit chat. I don't know. It's kind of boring because I have that awesome RAM tester that a viewer sent in. You just pop these in one at a time and test and mark whether it's good or not. And then also write if it's 1 meg or 4 meg or whatever. And yeah, it looks like we have some additional memory here. Also 30 pin, which is cool. Oh no, it's a mix of 72 pin and 30. So the 30 pin memory will all go together into one bag, which I have a big bag of stuff to test. And same with the 72 pin memory. All right, and then the final thing we have is what's in this box here. My assumption is we're talking about a motherboard of some kind, but I might be wrong. Oh, yeah, we do have a motherboard, and this is an old motherboard. ThinkPad utility disks. It's kind of cool, but this is not a ThinkPad. This appears to be 486DX33 VLB, Matte Sonic, Aladdin Pro 2 chipset, 8 megs of RAM parity, and has 64K of cache memory. That's kind of cool, Lawrence. How long had this been floating around? Was this in the office or is this something you had at home? I would be surprised if any kind of office had something as old as this sitting around for all that time. And will it have battery damage? That's the thing before we flip this over. These very often have Varta style NiCad or nickel metal hydride batteries, and it does have the space for it. And that looks like it was never installed. What? Like someone must have been using an external battery with that. What's interesting though is I think when you have the jumper on there, that actually hooks this internal battery up, and you remove that and then you can connect your external battery right there. Let's see the back side. That'll sort of give us an idea. No, does that look like someone has desoldered the battery? Well, either way, if that has happened, it happened before any kind of corrosion set in. Yeah, there's a bit of flux right there. So someone must have done a really good job desoldering whatever original battery was on there. Wow, that's cool. One of the big downsides with 46 motherboards is unlike with Pentium motherboards, everything is set with jumpers on these. So if you're changing the CPU out and you're not going from like a 33 to a 66, which wouldn't require jumper changes, but if you're doing anything else, you gotta switch jumpers. And figuring out which jumpers to change can be kind of difficult, hence the need for their wonderful website, the RetroWeb. Let's see if we can find the details on this motherboard here. So it says M601. For the socket type, it's PGA, but I don't remember how many pins. 169 pins, so that's the low insertion force version of what we have on here. The closest we have is 168. Now I think what's happening here, if we just pick that and we go back here, this has one extra pin here, and that's for the overdrive chips, I think. And it's not necessarily used, so we're gonna do, 168. Let's just see if we hit search, what we get. Okay, I'm pretty sure that's the motherboard we have here. This is 1.3B. So this may not actually have, oh, there it is. This may not have the exact whatever change the 1.3B brought to this board over this 1.3A. But taking a look at the photograph, this is without a doubt the same motherboard that I have in my hands here. So other than that slight version change, it's all the same. We have a package here that's not installed on the board, and I'm just quickly looking. Everything else looks on first glance exactly the same. There may just be some very minor changes to necessitate the A or the B revision here. Maybe like they installed an extra resistor or things like that. If we click on the documentation tab though, we have the manuals right here, which is excellent, or at least part of the manuals. And here is what I was talking about for like the CPU jumper settings. So it's a good top tip from me to you. If you're looking to get into 46s and you're shopping around online or locally or whatever for these types of motherboards to put into a PC you're building, I really recommend you try to find the information on the motherboard first. So ask for some high-res pictures if you can't tell like what model numbers it is, or they don't list that, and then go find the manual. Make sure the manual matches the motherboard and the photographs, and that the version number is the same, because I have had motherboards where there's generally information on it online, but the version doesn't match, and then the jumpers have been reconfigured. That can really throw you for a loop and prevent you from actually successfully getting a working system. Because if you change the CPU, like if you just use it as is right here, maybe it's going to be fine and just work. But if you try to swap the CPU to say increase the performance or whatever, then you might get stuck not knowing how to get the jumpers configured. And it means that you might have wasted your money buying something that you can't use. So yeah, I really recommend try to do the research first before you plonk down any cash on motherboards. There were a lot of clone manufacturers making these motherboards at the time, and unfortunately some of them look very, very similar to another. I have some that have like subtle differences, different brand names, and then they've moved and reconfigured the way the jumpers work, and it's just not compatible. So that's my little top tip. Let me grab a power supply so we can test this thing out, and the video card as well. All right, the motherboard is connected up to my power supply, my usual bench one. I have the post card in there. Let's tilt this over here, zoom in a little bit. I don't have anything else hooked up. I do have the video card ready if this thing does work. Turn this on, and that's not a good sign. It says E1, but it went straight to that. That does not indicate a working system. Let's power cycle this again. Comes out of reset. Yeah, this is the reset light. Turns off. That goes to there, which is normal. And we're getting nothing. Not sure what that E1 was all about. Let's see if the CPU is warming up. Not really feeling anything. So for posting to work, you don't need memory. You just need a CPU and a working BIOS chip. And the rest of the motherboard, of course, needs to work. I think we should, let's see, what we're going to do next. I guess we should check jumpers. That's what we're going to do. Okay, well, I figured out our first problem here. So we're looking at the clock speed settings here. Shows 3 different clock generators, and the one that's on this board is none of those. That's the clock generator right there, and well, it's not any of those. This is a PLL something or other chip, and these model numbers here don't match. Scrolling down here, that's cache memory, and scrolling up here, there's CPU selectors. It is currently set for 4060X, so 1, 2, 3, 4 for JP16, which is right here, and JP17, 1 and 2 is right there. So that's correct. But this clock synthesizer stuff may not be correct. Thing is, we can kind of assume this stuff is correct. Let's move this over, by the way, because of course this system was working probably when it was put away. So it's unlikely that anyone's manipulated these jumpers in a way that makes it not compatible. Now the problem is here, JP7 only shows 3 pins, but this thing actually has 4 pins. So that additional pin must be needed for this clock synthesizer. Just for fun, I'm going to remove one of these, I guess. Let's see if that makes anything change at all. Nope. I'm just sort of fiddling around with jumpers here, see if anything changes. It's acting exactly the same. And indeed, this thing appears stuck. Now, one of the issues is we don't know the history of this thing. I don't think the CPU is bad. It's extremely unlikely. But maybe there was battery damage that I don't see. Maybe the BIOS chip is dead. Maybe the chipset is dead. Maybe there's a cache memory problem. There could be all sorts of issues. I think probably the easiest thing is let's just pop this RAM out of here. RAM shouldn't matter for it not posting. Like, it shouldn't cause it not to post. But I don't see a lot of 244, 245 bus transceivers on here. So I'm assuming the RAM must go directly to the chipset. So let's just pop it out. And we're still not getting any kind of posting. Nope, nothing. So maybe it's, it's possible that the RAM could cause kind of issues. But I think I'm going to get the BIOS chip out next. And that's because we can pop this in the programmer and at least we'll try to read it. Because if this is dead, well, if I turn the computer on here, obviously we're still getting nothing. If this chip somehow got erased or something, which is possible, this is not an EPROM. This might be a mask ROM or something like that. If this got erased or is bad, then yeah, this computer won't do anything. It will do exactly the same thing as it has been doing. So we need to try to read this in the EPROM programmer, but I need to know what kind of chip this is. So I'm peeling the label back. The marking on here simply says that. I don't even know what that means. I'm gonna have to assume that this is like a 27512 or 27256. Oh, you know what? Let's look at RetroWeb at the size of the EPROM dump that's on there, and that'll give us the clue as to what size this is. Here on RetroWeb, we have one BIOS image. Let's download it. And the file is 65 kilobytes. So if I am not mistaken, that's a 27512. So over here on my Mini Pro software, we'll just pick any old random chip. And let's try to read this in. Ah, yeah, I had the chip in backwards in the Mini Pro. Luckily it has that overcurrent protection stuff built in, so it doesn't cause any damage. Okay, there we go. All right, well there it is. That does not look like it's missing. The date in here is 1993. Let's just check this against what's on Retro. The date is 93, and according to this, this has 8893, which does match this version here. So let's load the file that I just downloaded into here, and I'm gonna compare. So we're gonna hit verify, which is here. What this does is it takes the file in the memory of the software and then compares it to what's on the chip. All right, so it is different. Let's verify to all. So there are 4 differences. Now that just could be because the version is slightly different. Let's see if I can find those differences. Like there's 2 bytes there that are different. See, it marks them in red. So this sequence of numbers starting with 40, ending in 4386, this is like the actual version. So let's load, and actually that's not different. So if we load what's off the chip, there it is. Yeah, it's exactly the same. So that might indicate that there are a couple bad bytes in this ROM chip. So let me go find another 27512 and I'll flash that. I was looking around in my little pile of chips here for 512s and I didn't find any, but then look, these are the chips that actually came with this mail call package. We hadn't looked at these yet. And here are some right here. And they appear to be blank. It's ST27C512. So I have it configured for the right chip. I have the file loaded off the hard drive. Let's program this. The ID check passes. And then, well, maybe this will fix the motherboard. We can hope, because there does seem to be a few bytes on here that aren't reading properly. Programming complete. I'm going to turn this off. I don't want to put the chip in while it's turned on. Let's just straighten these pins out since this thing is definitely never used. Pins are a little splayed out. Let's get this chip into the motherboard there. The notch is towards the back of the motherboard as it is with this. In fact, it matches the other chips. Let's try this. Even without RAM, it should work. Nope, that was not the problem. Well, that's a real bummer. The CPU is warm. It's been running for a while. I could try another one with the CPU removed. If we turn this on, it's just going to do exactly the same thing. Without a CPU, it just comes out of reset. Nothing else happens. Here's another 486DX33. So we have the exact same part number. Notch is right there on the motherboard as it is on the chip. So we'll push this in like that. Here we go. Yeah, no change, nothing at all. We're seeing no signs of life out of this thing. I'm just gonna go back to the original chip that was in here. We don't need to have my known good one in there, which is this one right here. Interesting is this one doesn't have the little white dot on the corner there with the notch. Let's take a look at this frequency synthesizer. We have a PLL 52C05. And as usual, not really finding anything here. Of course, this website, the worst website ever, the scourge of anyone trying to fix old stuff. You're like, oh sweet, they got a data sheet. You go here. No, there's no data sheet. There's data sheets for a bunch of other chips, similar, but not what we're looking for. Tons of people selling the chip though, you know, fake ones or whatever. Here's a motherboard that maybe uses this exact chip. This actually helps us. I was going to say this doesn't help us. Look how this looks like the same information as what we're looking on the RetroWeb, but there's an extra set of jumpers. So JP7 needs to be 2.3, JP8 needs to be 2.3, and then JP24 needs to be 1.2. I don't think these numbers necessarily match, but maybe they do. And unfortunately, these jumpers don't match. So this jumper here is labeled as, looks like JP9. This one up here is JP7, but it has 4 pins instead of 3 pins, and there doesn't appear to be a JP8 at all. This jumper down here doesn't actually have a visible jumper number. It has JP9, I think it's for this one. That's JP18, which is not installed. Like I said, JP7. I mean, we could assume that this one is maybe JP8, but we're missing JP24 as described on that data sheet I just found online. So this definitely goes back to what I was saying. These motherboards were made by many manufacturers, and there are slight changes from one to another with different brands and silkscreen markings, and I've run into this exact problem before, where sometimes it's impossible to find what you're looking for when it comes to the jumper settings, and that can make it where there's no way to get these things working. I have the oscilloscope up. Let's just poke around what we see on this chip here. Well, we're getting some kind of clock signal right there. 14.33 whatever megahertz, so that's the normal NTSD style clock. That pin has nothing. This pin has 33 megahertz on it. Okay. Well, that kind of tells us that that's the correct clock. Let's power cycle the computer here. Yeah, it goes right to 33. Let me try changing some of these jumpers here and just see what happens. Oh, that changed it to 32. That's a bit odd. That didn't do anything. This one here didn't change anything. Oh, there are 2 positions here. Let's try the other one. Nope, no change. How about this bottom one here? 25, okay. So 25 in that position, 33 in that position. I suppose we could try the 25 position. Let's power cycle the computer and put the postcard back in, which I had taken out. Yeah, we're getting nothing still on there. So even though the RAM's not installed, it would be beeping at us, and we would have postcodes if this machine were working. Just for fun, I'm going to reinstall the original BIOS chip here, and we're still at 25 megahertz. And yeah, that's not doing anything. So same thing. So I've ruled out that it's not the clock generator. We're getting 25 megahertz or 33. It's not the CPU. We swapped that out. It's not the RAM because I removed that. It could be the cache memory still, but more than likely there are some other fundamental problems on this. Could be a bad chipset. It's really hard to say. So I think I've reached the end of my troubleshooting for this particular motherboard, at least for a mail call video. It's very difficult to troubleshoot these because you don't have data sheets for the chipset. We don't have schematics. Outside of basic troubleshooting, which we've already done because we've swapped out the CPU, we know that's not the problem. We've taken the RAM off, so we know that's not the issue. And I've even made a new BIOS chip, so we know that's not the issue. It's really hard to say what might be going wrong with this motherboard. So if you have any thoughts about it, we saw that one postcode, E1. If you have any thoughts about what this might be, definitely let me know in the comment section. But otherwise, I'm just going to mark this as not working. I need to find my marker. Over here is 1, so I'm just going to put no post on here. And then maybe at some point in the future, this will be a future troubleshooting video. I have a pile of hardware over there that is not working and needs future testing. And moving on to the last thing that Lauren sent in, I'll just slide this stuff out of the way here. We have lots of chips. Let's take a look at what these are exactly. So everything's pretty nicely labeled. We have some D43 256s-70s. These are 32K by 8 SRAMs. If we look at the motherboard here, we have these chips here, which are 27C 256s. So these are 32K SRAMs as well by 8. And this is a very similar, wider package. The fact that it's 70 means that maybe that's kind of slow. These are -20, so 20 nanoseconds. These are potentially 70s. These are still very useful. Like this could work in place of, say, an EPROM, like a 27C 256. So this would give, well, you can't obviously program something into this and then stick it in a motherboard, but you can probably install these into something just like this, which is designed for 27 256s. And I think we have a switch here, and it's hard to see because the switches are blocking, but switch number 6 actually enables writing. And it would turn this card from just something that can hold an EPROM into a little RAM card, actually. So this would extend and give you high memory on the ISA bus. In case you're wondering what this is, it's the Monotech ISA double ROM card. I only have half of this installed, but yeah, you could put 2 of these into here, and it would give you 64K of high RAM. Each one of these is 32 kilobytes, just like this EPROM is right here. Looking at these chips here, looks like we have another tube of those. That's pretty cool. And we have a tube of 27512s. That's just like we used a moment ago to program the motherboard BIOS chip. Looks like we have another tube of those. That's cool. I actually have tons and tons of 27256s. They're in this thing here. These are all erased and I just need to sort them out, which is why they're all sitting in here. I don't have that many 512s though, so that's actually pretty handy. We have the 82C51As. And according to a Google search, this brings us to this Intel part, 8251A. Is that what this is? 82C51A, so same thing. And we have a programmable communication interface, synchronous and asynchronous operation. It looks like it's for serial ports from DC to 19.2K baud. I don't think these are used in PC serial port cards. I think these were used in older 8-bit peripherals. Don't quite remember. If you know off the top of your head what systems typically use these Intel parts, let me know. Next up, we have more SRAM, 6T1008-70, so 128K SRAM. These will have, yeah, these are larger packages than the other one. Then we have another tube of the serial UARTs again. And then we have a third tube of the serial UARTs. And another tube of the 128K SRAM. These are all super useful chips for projects. And this here, this is another tube of the 32K SRAM. Oh, it says it right here, 32K by 8. And we have a fourth tube of the serial UARTs there. And we have yet another tube of the 128K SRAMs. And another tube of the 32K SRAMs. And lastly, we have another tube of 128K by 8 SRAMs. And that is everything that Lauren sent in, including this awesome picture of Rammy, which Rammy appreciates the likeness, and this RAM here, which Rammy will munch on later. So thanks again very much, Lawrence, for sending this stuff in. If anyone has any ideas of what might be wrong with this motherboard, definitely comment down below. And I'd also love to hear people's thoughts and opinions on these various slot-based processors. I'm obviously not a fan, but that doesn't mean that you aren't. So yeah, tell me your stories. Let me know if you love or you hate these, especially the fact, like I said, that the Intel and the AMD ones look so similar. I do notice that while the labels are facing the same direction, the notch is in a different position. But if you just flip this around, then they look identical. But then if we look at the sides with the notch in the same spot, I don't think it would actually slide into the plastic holders that are on the motherboard because it would be reversed. So that was the way that AMD differentiated their chip, by flipping the orientation of the connector on the motherboard. How freaking original. Okay, so I want to open up another package here, and as you can see, I have already opened it. And that is because I thought I was recording, but I wasn't. So I opened this, I read the letter that it came with, I looked at the stuff that was in the box, and none of that was recorded. That is completely my fault. I just didn't hit record on OBS. So let's start from scratch again. And this package here, which I've already opened, comes from Chris. Hello, Chris. Let's take a look at the letter, because the letter explains what is going on exactly. Chris has a website here, My Geek Hobby, and in fact, let's zoom up on that QR code. So if anyone wants to scan it to check that out on your phone, you can. Chris writes, as per our conversation at VCF Midwest, I'm shipping you my EPROM emulator. It's an open source project with documentation right here, GitHub. I super duper approve of open source hardware. That's absolutely amazing. I recommend before you start using it, check out how others have been using it. So we have another URL here. I'll put these URLs in the description below. To use this, you're going to need a serial port driver for the Arduino Nano, so a CH340, I already have that. Python 3.8, you need a library, PySerial, PySimple GUI, and then this script right here, which I guess is for the EPROM emulator. We have a YouTube video here to show how it works, and you can use it from the CLI by running this Python command, and if you do not invoke it with anything, then I guess it starts a GUI. And then right here is the emulator, which I've already opened. Now, as far as what an EPROM emulator is, you might be wondering, what exactly is this? I've made some videos in the past about diagnostic ROMs that myself and my friend David worked on. And while we were developing those, like one for the Apple II, and there was another one for Z80 based machines like the TRS-80, there was so much taking the chip out, programming it in the programmer, putting it back into the computer, testing, oh, it didn't work, change some code, take it out, put it back in the programmer, you know, erase it, all that kind of stuff. There was so much of that back and forth. It was super duper frustrating. And I bumped into Chris at VCF Midwest, and Chris told me that, well, he created this open source project that's an EPROM emulator. And I know there's commercial versions of these that are very expensive, and I'm sure there are other ones out there as well that are probably open source. I don't know. I've actually never really looked into it. But Chris's right here has the ability to emulate up to, I guess, 128K, because this is an SRAM chip here of 128 kilobits. In fact, it's a 1008, which is the same as the SRAM chips that I have several tubes of now that we just got from Lawrence. So this would hold your development code, like your ROM code. While this is powered up, the logic here would then emulate the EPROM, and it comes with this cable here, which plugs into that pin header there. And it has this, which goes into your EPROM socket on the motherboard. It has a couple pins here. I'm not sure what these do. Maybe it's power, something like that. And then when you turn your computer on, this thing acts as the EPROM, and it's all coming out of this SRAM chip here. So then when you figure out that you have a bug, all you have to do is recompile the code or relink the code, push it up into the SRAM chip, power cycle the computer, and you should be good to go. How exciting is that? So yeah, let's go take a look at the GitHub repo to see exactly the specs on this, and let's go from there. So here we are on the repo for this particular project. Let's scroll down to the specs. Ah, there it is. Reset hooks can reset the target. Oh, that is so cool. So you connect that to the reset line. So as soon as you upload the new code into the SRAM chip, boom, resets the computer and then keeps going from there. We can read more about it on his website. We'll open that up in a separate tab. It looks like there are some available on eBay because people are probably going to be wondering how much these cost. Here it is. This looks like exactly the same kit that Chris sent me. Thank you very much, Chris, for that. Really nice and generous of you. $75 for this EPROM emulator fully assembled. And we can see right here that it emulates from a 2716 all the way to a 27512. That means that on some computers, well, we'll read more about this in a second, but I have a feeling that on a computer that requires like a 2364 EPROM, that would be like a Commodore 64, you'll need to use an adapter. And those are commonly available, little PCB adapters that would convert from a 2664 or 2764 down to a 2364, which is a mask ROM of the same capacity. Chris writes he has a commercial EPROM emulator, the ER Max 100. I've been using it extensively and discovered a few really annoying features of the emulator. So he was motivated to create something similar, but using a modern microcontroller and of course, open source, and it's cross-platform because it just uses Serial and Python that can run on anything. It has no annoying limitations of the old device, more on this later. So there it is, the final result. So Chris demonstrates right off the bat on a 64 plugged into a cartridge, and therefore this instantly becomes like a universal cartridge for the 64 where you can just load any software. You just take cartridge images, push it up into the emulator, and reset the 64, and there you go, you're off to the races. And then here's a picture of Chris using it with a Z80 to create a monitor or like a boot ROM for a little single board computer. So I want to actually see this operating. So what I'm going to do is I'm going to grab a motherboard to get the software all set up, and we're going to see this actually working. For testing, I'm going to be using this Apple IIe motherboard here. I have a speaker hooked up and the power supply, and this is working as it sits right here with the original boot ROM in here. If we turn the computer on, there you go, you see the Apple II prompt. I went ahead and I followed the instructions on installing Python and the various libraries this needs, and we are actually ready for some testing. I did go ahead and install an extra socket here onto this connector, and that's because the pins on these IC socket type ribbon cable adapter things are very fragile. So this round hole socket is a little bit more sturdy, so I can hit those pins and nothing happens. So I recommend you might want to do this as well if you're using something like this. The two clips here are labeled. This one is reset active low, so that would be like a 6502 processor like on this Apple II, and this is for reset active high, which I think might be like Intel processors. I can't remember off the top of my head. I went ahead and removed the two pull-up resistors on the address lines. I'm not sure what systems need these, but definitely 6502 based systems do not. On the Apple IIe, this ROM right here, this is the EFROM, which is the one we want to replace. This is the boot ROM, and it's the equivalent of a 2764 EPROM, even though this is a mask ROM. So all we need to do is plug the EPROM emulator into the motherboard like so, and then since we're dealing with a 6502, we're going to use the active low reset wire here. I'm just going to pull a little bit extra off of this ribbon cable. And on the 6502, the reset line is pin 40, like that. And we need to power up the Arduino, so we'll plug that into the computer like so. Here's the Python script that I downloaded from the GitHub repo, and I created a couple batch files here just to help me in programming this thing. The batch files are helpful because you can enter the command line parameter, but I'm passing it the argument of %1, which means I can just drop a file onto the batch file, and then it will actually program this little device. Notice here the 2764 batch file is set up for a 2764, which is exactly what is on this motherboard. And here's some ROM files to program onto the emulator. This happens to be an Apple IIe unenhanced, so you got to use the matching unenhanced ROM. So we'll just drop that onto here. It's about to load this into the emulator. You push a key, and now it's going to actually program it. Now, the Apple IIe is off in this case, but we'll show it programming while the IIe is on. Okay, so it's finished, and if I turn on the computer, there we go. You see that it booted up normally. Now I have the dead test ROM that me and David worked on in this bin file right here, and I've padded it out because the dead test ROM normally is 2K and needs to be an 8K file. So I copied it 4 times into a single 8K file, which is right here. And if we drag this onto here, and this window keeps opening off screen, and we hit spacebar, it's going to program. You notice the cursor has stopped flashing on the emulator, and there it goes. It's now running the dead test ROM. That's all it took. It automatically reset the computer. I didn't do anything there. It was just automatic. Now I have a modded version of the unenhanced ROM, so we'll just drop this onto here and move this window so you can see it. Hit the space bar, and what will happen is the dead test will stop running. And well, you can't really tell, but anyways, there it is. It's rebooted, and you'll notice that this modded ROM is simply modded where it says Adrian 2 instead of Apple II. I just did a little bit of hex editing on the file, and it was that easy. But I can easily switch back to the original ROM, and I know you can't see what I'm doing, but I just dragged the original EPROM onto the batch file. It's currently loading. Notice it kind of corrupted the screen a little bit, and there we go, it rebooted the system. So I have to say, this thing totally rocks. It was quite easy to set up. That Python script works really well. The directions that were included with the letter that Chris sent here were very easy to follow, but that stuff is also on the GitHub repo. Well, actually, I think it's on his website as well. So I just followed the directions exactly as he said, and this thing just freaking works. Now, one thing I didn't notice about this is it looks like there's an SPI ROM on this board right here, this little surface mount component. And if we take a look at the batch file, there is a flag here for SPI, and it says no. I haven't tested this, but I'm pretty sure if I say yes, what happens is once it loads the code into the emulator, it will also load it into the SPI ROM. And what that means, as far as I can tell, is if you power cycle the emulator, it will automatically come back with the last ROM that you programmed onto it. If you're doing a lot of development over and over again, you probably don't want to reprogram the SPI flash over and over again. But as soon as you're ready to have like long-term testing with the emulator, you can probably just change this to yes, and you're good to go. There's also an auto command here. Why? I think what that does is it won't start the emulator until you push the red button on it. So it allows you to get ready to monitor your system under test, and then you push the little red button on there and it will start. I've had this set to Y the whole time for testing. So let's change this to SPI yes, save that, and I'm gonna drag the Desktest II EROM here onto here, and let's program this again. Let's see what it says. So memory map disabled, I'm not sure what that means. Uploading files, so yeah, save, oh, it went away super quickly. It said something there about saving it to the SPI. Okay, so it's running the dead test ROM right now. What I'm gonna do is I'm gonna power off the computer, and I'm gonna power off the emulator. In fact, I'm just gonna unplug it from USB entirely. So we'll let it power itself from the motherboard. I think that actually does work. So if we turn the computer on now, yeah. So that incredibly quickly loaded the SRAM on the emulator from the SPI, and that's really cool. There was probably a little bit of a delay there where I assume it holds the system in reset, or maybe it does reset the system as soon as the emulator is ready. I'm pointing to it, it's off camera there. Let's just try that one more time. So if I hold this like this, you see that the power lights are off here. And if we turn it on, there we go. It came right up. So it's powering the entire emulator from the motherboard over this ribbon cable, and it just works. That is a really, really cool feature as well. So what a freaking awesome project this is. I have to say, Chris, thank you very much for sending this in. I have really needed to have something like this for the longest time, and I'm really glad to have finally gotten this. And as far as I can tell, this thing works absolutely perfectly. Remember the caveat that if you're trying to use this emulator with a system that requires a 2364, and that would be something like a Commodore 64, you're going to need a little PCB like this that adapts the 2764 down to the 2364 footprint. So really, Chris, this is a freaking awesome project. Thank you very much for making this. Thank you for making it open source, and thank you for sending one in. This will be so super helpful for the next time I'm working on any kind of ROM testing and need to constantly make new ROMs, because like this is the PCB I used for doing the Apple II test ROM development. And I mean, I must have taken this chip in and out of here so many times, and this would have made that so much easier. All right, let's continue on the Apple II train, since this package here I'm pretty sure is for the Apple II. This comes from Bradley Bell from Seattle. Brad has been working tirelessly on recreating all sorts of Apple cards in an open source way, meaning they're all on his GitHub that you can download and make yourself, just having the PCBs manufactured at your PCB manufacturer of choice. He has previously sent in an Apple II 80 column card that was a recreation, a Disk II card that was a recreation, and I'm pretty sure I'm forgetting other things. Now, Bradley and I have been chit-chatting about a project that I think is super cool. And what it is, it's a Disk II card. So this is a card that goes into your motherboard for connecting up to floppy drives. But unlike the regular Disk II card on, say, the Apple II Plus or the Apple IIe, this one supports SmartPort devices. And it's totally open source, meaning you can make your own. You don't have to go buy one of the very expensive replicas or one of the original Apple II cards that cost an absolute fortune. If what's in here is what I think it is, then this card should do the trick and be very inexpensive in the process. All right, let's see if it is the card that I think it is. Yes, I'm pretty sure it is exactly. Yep, that's it. This is what I think it is. Now, if you're a big Apple II person, you may or may not know that there is a SmartPort kind of emulation card sort of out there already. It's called SoftSP. What that is, it's a little card that has a ROM called SoftSP on it, and you use that card plugged into a slot in your Apple II. Like, let's take this motherboard. You plug that card, say, into slot 7, a little card that has just the SoftSP ROM on it, and in slot 6, you put a normal Disk II card, just a standard Disk II card that you would use with regular Apple II disk drives. Well, if you turn on the computer and you type PR number 7, what happens is the SoftSP ROM in slot 7 takes over the Disk II card and actually will talk to it as if it's a SmartPort drive or controller. So if you have a floppy EMU plugged in there with the SmartPort firmware on it, it will actually boot SmartPort hard drive images right off your standard Apple II disk controller card. Well, the author of SoftSP actually released a version of this ROM that could work on a Grappler printer card. So you could take the Grappler Plus parallel printer interface card, which had a ROM chip of its own, swap out the ROM with SoftSP, plug that into slot 7 or any slot really, except for slot 6 where the disk controller is. And then when you typed PR number, whatever slot that Grappler card was in, it would do the same thing. It would then treat that Disk II card as a SmartPort card. Well, originally I was talking to Bradley about recreating just the ROM portion of the Grappler Plus card, that parallel printer card. Because when you look on eBay, those Grappler Plus cards are available, but they're kind of pricey for whatever reason. I don't think they sold that many. The regular low-end Grappler card, that's also a printer card, those are very plentiful and super common, but those are not compatible with the SoftSP ROM, only the Grappler Pluses. So luckily the schematics existed for the Grappler Plus, so Bradley started recreating that and made a replica of that card and then proceeded to take away all the parallel port stuff that's no longer needed and only keep just the ROM portion, because there's some ROM banking that's required on that card, so there's a bit of logic there. But then Bradley had a really cool thought. What if he takes his already open source Disk II replica card and that ROM card that he's created and merges them into one to create a card like this, which is just simply a disk controller card with the SmartPort ROM on that, and this thing will actually work directly with SmartPort devices. As far as I'm aware, this is a working one of those cards, and this is totally open source, and he got permission from the author of SoftSP to include the ROM here, so I'm pretty sure that this ROM is on his GitHub, although I haven't looked at it, and I don't remember exactly what he said in the email to me about this. But let me grab my floppy EMU, and let's try this thing out. Now, when we look at this card, there are connections for 2 separate floppy drives. I don't know for sure if this card works as a regular floppy controller. There is a jumper right here, JP8. So I wouldn't be surprised if it could possibly work that way. A little bit of a bodge on the back there. This is version 3 of the PCB. There may be newer versions out there on the GitHub repo. But if we look at the silkscreen marking right here, it says drive 2 for this one on the left, or on the right, drive 1/SP or SmartPort. So if we take my floppy EMU here, we don't need this little adapter that's on here to plug into the 19-pin connector for like an Apple IIc or whatever. And we're gonna just plug this into here. Luckily, Bradley used keyed connectors, so you can't plug that in backwards. And I'm just gonna pop this into slot 7 here on this motherboard, and let's do some testing. Okay, so we power this on. The floppy EMU powers on. That's a good sign. The Apple II, as you can see there, is just at the prompt there. It didn't try to auto boot. I think that's normal. That's the way SoftSP ROM works. Make sure my keyboard works, and it does. All right, I'm going to switch this over to SmartPort mode. I do know that there's a new firmware for this that has a more functional SmartPort ROM. Lets you pick what image you're going to use, stuff like that. It asked me to power cycle the computer. Okay, so total replay is currently selected on there. I have the board here in slot 7. So if we do PR number 7, oops, that's not gonna work, is it? PR number 7. Oh, it freaking works. It freaking works. Look at that. So yeah, the color graphics, ignore that. That's just a RetroTink thing. So there we go. An open source SmartPort card. I mean, yeah, like the original Apple II one is called the Liron, and there's a clone version of that uses either like an FPGA or CPLD, and it completely replicates the original Liron card. I think Big Mess of Wires makes that. Yeah, here it is. It's the Yellowstone card, and I think it's been out for a number of years, although maybe it's not. There's the original Liron card. I don't know what's wrong with the picture. Uses the integrated WAS machine, the IWM chip, which is also used on the 2C. And on the 2GS, that has a little surface mount type package or a little PLCC package. And Macintoshes use that chip as well. It has its own ROM. Let's see if we open this in a new picture. It won't look so squished. Yeah, there we go. That's how the card looks. So that's the integrated WAS machine chip that's from those other machines. So for whatever reason, this card is very expensive and not super common. And it would be very easy to replicate one of these because all these components are pretty much off the shelf except for the integrated WAS machine chip. You would have to pull that off another working Apple computer, or maybe a non-working one, but a Mac or 2C or whatever, and make this card. So until someone comes up with just a replacement for this chip, like an FPGA version or maybe a Pi Pico or something, which would be amazing one day if someone could do that, by the way, because those chips do die occasionally, and then you lose your floppy drive functionality on your Apple IIc, and you have to steal one of those chips off of another machine. Anyways, if that chip were replicatable easily enough, it'd be very easy to replicate just this card here because the rest of those chips on there is like a ROM and just some logic chips. It'd be very simple. But the way the Big Mess of Wires went about it is with this Yellowstone card here, which I think does everything inside this one chip. I guess even the ROM, or maybe that's an SPI flash there. I don't quite know. I think this has more functionality than the original Liron card. Like this thing can do all sorts of things. And I think this here is the production version of it. And let's see. Oh yeah, so yeah, you can add 3.5-inch drives and SmartPort drives. But if you do want to buy this card, which incidentally is not open source, it costs $139. So it's not like super expensive, but that's also not particularly inexpensive either. Compared to the fact you can go to GitHub here, go to the SmartDisk II project, which is the one we're looking at here, have this PCB made up, and it's a very small PCB, so this fits in like the $5 PCB thing if you use your favorite PCB manufacturer. And then all of the components that are on here are completely off the shelf, nothing custom at all. You can see right here, we have a 27256, we have a 2732 EPROM, that's for the P6 part, and the rest of these chips are just standard logic ICs. So it's very easy to build, totally through hole. Anyone can do it as a hobbyist. You could just buy these parts from anywhere. You just program them with your simple Mini Pro type programmer. And then now you have an integrated all-in-one SmartPort controller for any Apple II that has a slot. This is freaking awesome. I cannot stress enough how cool I feel this is. Let's switch the mode here so we get some color. So we're not looking at this black and white here. There we go. So let's try to load a game directly off this thing. It's just been showing like the regular demos. It might have crashed actually. And you know what? I noticed that occasionally happens with the total replay is it will be sitting there with the demo and occasionally it just freezes. And that just happens on anything, like even plugged into an Apple IIc directly through SmartPort. I was gonna say control reset normally breaks you out, but it doesn't seem to work in this case. So we're gonna power cycle the machine. Oh, it didn't wait long enough. Yeah, you gotta wait a little bit longer for the RAM to decay for an Apple II to properly cold cycle itself. Okay, there we go. PR number 7. Let's load that up again. Total replay. Boom! It just works. So easy. We'll load a game here. I was going to try to load Droll. Oh, there it is. I love this game. Super fun game. Originally written for the Apple II by Broderbund. It was ported to other systems. I think the other versions on other systems, there's no actual improvement. It's the same game on everything. It's very fun, and it's actually quite hard, but it's a neat game. I forgot how to move. Okay, arrow keys. And I think A and Z. Oh, we're watching the demo. I think. I don't know. Yeah, we must be watching the demo. Because I was like, I don't think I'm controlling it that way. I do want to give an honorable mention to Bradley's other projects. So for instance, here's the Disk II controller card that this project was actually based off of. So there it is. So if you don't have a Disk II controller card and you want to make a replica, you can do that as well if you don't want to go ahead and make this one. There is, of course, the replica language card, which is what I use as well. And Bradley has recently modified this as well to add a toggle switch so that you can have a ROM on here with a couple different ROM images. So for instance, in an Apple II Plus, you can switch. This is a 3-position switch. You can switch between AppleSoft ROM, Integer Basic ROM, and then also, for instance, you can have my dead test ROM, the RAM test ROM on there as well. And this sticks through the back of the computer on the Apple II Plus when it's in slot 0 for the language card, and you can just flip that switch very easily to switch between those different ROMs. This is based off my friend Frank's design, IZ8DWF. He originally created one that did this exact same functionality, except I don't think he had a switch on it, and it was all surface mount. So Bradley recreated it all through hole, so for very easy assembly by anyone who doesn't have a lot of skill. This card works absolutely fantastically. It's all very easy to get parts. There's no ribbon cable needed to go to the motherboard, none of that, because this uses static RAM, so there's no RAM refresh required, which is what that little cable is for on the original cards. We have the 80 column card here, which is the Videx 80 column card, and it's a replica as well, and it works perfectly well as well. This is in my clone machine upstairs, and it works great. But the star of the show is definitely this SmartDisk II, because this is bringing functionality to the masses in an open source way that can be made very inexpensively. And notice what he writes. This is a Liron card with the IWM or integrated WAS machine replaced by discrete components from the Disk II controller, which the IWM was originally based on. So yeah, the IWM was Apple's attempt, or not attempt, they actually took all the discrete components from the Disk II controller, shrunk it down to one chip, and it was, I think, designed for the Apple IIc, so around 1984. It was also used on the Macintosh series as well. So I don't know where it came from, which of those two systems, but whichever it was, it reduced the number of chips required on the motherboard, and then that chip was used going forward on everything that had floppy drives. Later, there was like the super version of it, or the SWIM chip it was called, that allowed for 1.4 megabyte floppy drives, or MFM encoding as well. And Bradley writes a little bit more, because the SoftSP firmware as of version 6 is slot dependent. A different copy is required for each slot. The slot 1 version of this ROM is in the 1XXX region of the EPROM, slot 2, so far. A set of latches U9 is used to automatically select the appropriate region depending on which slot the SmartDisk II is placed in. Yeah, so originally when you had that SoftSP ROM, what happened is it could only use a Disk II controller that was in slot 6. So no matter where you put SoftSP in your Apple II, like say in slot 7, when you type PR number 7, it would then go to slot 6 and it would use that disk controller to boot the SmartPort hard drive. Problem is, it was hard-coded to 6, and that was really annoying because if you wanted to use floppy drives and a hard drive, you couldn't really do that. Later, the author of SoftSP came out with different copies of the ROM that could then address Disk II cards in different slots. So it was like hard-coded for slot 3, 4, 5, and so on. So as long as you use the appropriate version of the ROM on your printer card or on the original SoftSP card from the author, then you needed to put a Disk II controller into that hard-coded slot, so say slot 5, and you put the SoftSP ROM into slot 7, did PR number 7, and then it would go to slot 5 instead of slot 6. So in slot 6, you could keep a normal Disk II controller card. Well, Bradley went one step further, and he just included all the different copies of the ROM on this card, and then he detects where the card is installed. So it just uses the appropriate copy of the ROM for where this SmartSP card is in the motherboard, and then it will boot the SmartPort device, as you just saw. I was using slot 7. The card also works as a Disk II controller. For this, the OXXXX region of the EPROM contains the Disk II boot PROM, and U9 is held in reset. Plugging a floppy drive into the drive 1 connector should automatically activate the correct firmware because of the presence of 5 volts on pin 12. But you can also close jumper 8 to force the car into disk 2 mode. That is so freaking clever. Bradley, that is just really neat. So I don't know if on the newer firmware for the floppy EMU, you can switch more seamlessly between the regular floppy drive firmware and the SmartPort firmware. Why don't we give that a try though? I'm gonna plug this in back into slot 6 and I'm gonna turn on the computer and I'm gonna switch this over to the floppy firmware. I'm gonna load Shoplifter on a disk image. I don't know if it's gonna work unless we have to force it because I don't have a real disk drive connected. I have the floppy EMU. So PR number 6. Okay, so it's still in SmartPort mode. So I'm gonna power it off and I'm gonna put this jumper onto the card as instructed to force it. I'm gonna power this back on. Oh, I didn't wait long enough. This motherboard sports MT RAM, our favorite, and it holds the contents of RAM for so long when you power it off. So sometimes you really have to wait like 20 seconds before you power it back on before you can get a clean cold start. All right, there we go. And looks like it's trying to boot the firmware. Let's exit out in PR number 6. Okay, that time it worked. Or not. I mean, the light's on, like it's trying to access this thing. I'm going to switch to... Oh, this thing is actually... Oh, you know what? The floppy EMU crashed. All right, well, it doesn't seem to work with the floppy EMU. I'm going to go grab a real floppy drive because I would like to see this thing actually boot on a real drive, but I guess this card with the floppy EMU is not working. Now, I have used Bradley's Disk 2 replica with the floppy EMU, just the normal one, and it works fine. But this one does not appear to be the case. All right, so I have the SmartPort card plugged into slot 6. I have the jumper not set, so it's in SmartPort mode right now. And I have this clone floppy drive connected up. If we turn this on, let's see what happens. That sounds normal. We had the old head bump there. So I'm gonna stick this floppy disk in here. This has a game on it. I think it's Fat City, most likely. And we power on the computer. Oh, okay, it's Locksmith. Well, either way, it totally booted the system. So while it's not working on the floppy EMU, it's definitely working on this. Let's go to U. Although actually, you know what? This, while it started to load, it is not properly booted. Let's try that again. Okay, that time it worked. Let's do disk utilities, verify, fast sector verify, input drive 1. Well, it doesn't appear that this is completely working. I'm going to put this jumper on here. Let's see if that makes a difference. Not really. I'm pretty sure, well, I'm 99% positive that this floppy drive works perfectly. And the symptoms we're seeing here are very similar to what we were seeing on floppy EMU, where it kind of like loads a little bit and then it stops. Okay, that time kind of worked, sort of. This drive is very quiet, but I could hear it seeking there. Okay, so see, it actually finished loading there. So I go U, and we're gonna do fast verify. And then it tries to access the drive and then it kind of stops. All right, well, it looks like there's a little bit of work to be done on the Apple II Disk 2, compatibility mode. I mean, it's kind of controlling the drive. I could hear it seeking, it's doing stuff, but it didn't seem to load properly. And it was doing that off the real floppy drive here and off the floppy EMU. But in SmartPort mode, it does freaking work perfectly. And I think that's the main use case for this card. If you wanted to make a separate Disk 2 card anyways, you could. Bradley's version that's on his GitHub repo works perfectly. So you could have this in slot 7 and you could have slot 6 with the original Disk 2 card. I did show it earlier, but I just want to reiterate, it does not auto boot off this card. I think it's the SoftSP ROM. For whatever reason, it just doesn't support auto booting. No matter if you have nothing else in the system and you put that in slot 7 or 6, it will just drop you at the basic prompt. So you do have to type PR number, whatever slot this is in, to get it to boot. But that's a minor inconvenience and not that big a deal. And as I mentioned, this will coexist with your standard Disk 2 card anyways. You can have floppy disk drives and a hard drive, so you can boot hard drive images off the floppy EMU, or you can use other SmartPort devices and open source projects that exist out there. For example, the FujiNet, there is one for the Apple II, and it does work with this as well. I haven't tested it with this exact card, but I've used it with SoftSP, and it works perfectly. And over that connection to the external box. You can do like telnet connections, you can do internet gameplay, you can do all sorts of stuff. And that is all possible over SmartPort. There is also an Arduino-based SmartPort hard drive emulator, so you don't have to buy a floppy EMU, which is a pretty expensive device. This Arduino one just uses a little tiny Arduino like you can buy for a few bucks. I think it has a couple little circuits on there. I don't remember. I actually made one up. I think a viewer sent me the PCB for it. I don't remember. It's upstairs. I use it with my Apple II clone machine up there with SoftSP. And it's cool because it takes an SD card and it has up to 4 slots, and you can switch between which one's active. And then when you power the computer on, it will then boot that hard drive image. There are 2 versions of the Total Replay now. There's one like more sports-oriented games and one for arcade-type games. And you can switch between both of those and they work perfectly and all that stuff. So it's really cool that this thing exists. Thank you very much, Bradley, for working on that, figuring out all the details of getting it all combined into one little card like this. And then, of course, for sending me one of these, I'll be using this in my computer upstairs. I'll be pulling that Grappler Plus card out of there. And I like the whole idea of just using one single card versus the combo. So yeah, if you have an Apple IIe or an Apple II or II Plus and you want to use SmartPort devices and you don't feel like spending the money on the more expensive $140 Liron card, along with this thing, which is also like 140 bucks if I recall. So, you know, $280 between the 2 of them, and you want to make something yourself like this, along with an open source SmartPortSD device, you can get your Apple II booting hard drive images for next to nothing and using awesome open source projects like this. So I think that's going to be it for this mail call video. I think it's probably going to be pretty long. Thank you to Lawrence, thank you to Chris, and thank you for Bradley to sending in all this awesome stuff on here. And I'll put links in the description for all this stuff. Hopefully I can remember everything. If I don't, people will comment and then I'll try to add those links in the description. Thanks very much for watching. Thanks to my patrons. Their names are scrolling up over here, and they make it all possible that I do this. Patrons get early access to videos, stuff like that. Thumbs up if you don't mind. Subscribe if you don't mind. Really, really helps me out. Second channel would just super duper benefit from more subscribers. And I guess that's going to be that. So stay healthy, stay safe, and I'll see you next time. Bye.